I used the critical value approach as well as p-value approach to get the answer, and I showed you we can get the same answer by using either critical value approach or p-value approach. Okay, so okay, uh, these are the general steps for the critical value approach, especially for the critical value approach. Uh, Actually, between the difference between critical value approach and the p-value approach, like uh, I think which step maybe, yeah, maybe the fourth step is the different one. Okay, first of all, it doesn't matter p-value approach or critical value approach, you have to mention h naught and ha. Then pick the correct significant level. Most of the time they will give alpha. Okay, significant level h naught ha. Okay, this means this first one. Okay, then compute the critical value. So in the critical value case, uh, doesn't matter whether it is p-value or critical value, definitely you have to compute the corresponding critical value. Okay, so if it is critical value case, then you have to convert your alpha to a particular c value up to this point c value. Okay, convert it, and then you can compare your alpha, your C alpha and C cal. C cal mean your critical value. Okay. Then interpret your results. As I mentioned, never say you accept H naught or HA. Okay. We say we reject H naught, we do not reject H naught, something like that. We do not reject H naught because we don't have enough evidence, something like that. Okay. Okay. Why this come like this? They like merge each other. Okay, steps in performing analysis where sigma is known. That's what we are dealing with. Yeah. This is some kind of summary. The same page. I think they've just go one and another. Okay, just skip this one. This is the same thing. What I was talking about, two tail test, left tail and right tail. Okay, always H naught is this one. So this slide is not clear. I don't know, they just merge with this table. So anyway, this is your critical value or your C value. Yes, or C cal. Let's say C cal. So this slide, the same thing we discussed. So okay, check this example here. This example about right tail test. Okay, so they have mentioned average woman in her 20s was this tall, 62. So these are the observations. There are 3, 6, 9, 18, 20, 25. Yeah, there's number 25. Okay, so using this observations, you can find x bar, right? Okay, let's say 1% significant level alpha given, which is 0.1, right? 0.1 evidence. Okay, this is what they ask. Mean height of today's woman in their 20 is greater than, which means right tail test, right? Yeah. Oh, sorry. 0.01. Sorry. Okay. Thank you. 20 is greater than the mean height of women in their 20s. Okay. So greater than. This is the keyword. That's why I mentioned here keyword to identify the alternative hypothesis. Okay. You know, H naught always something like this. Okay. Mu naught you can find using this. Using this one. Okay. Clear? Okay, you know what's the equation to solve this? Since there are 25 and okay, let me check. there is a problem in this case. Okay, no, they have given, this is what I was checking. They have given normal distributed. Okay, otherwise it's going to be a problem because of this sample size. Now it doesn't matter, they have mentioned normal distributed, so you don't have to worry about it. You can use your C test. C, your critical value you can calculate by using x bar minus mu naught divide by sigma over square root of n. Okay, so if this value x bar here you can calculate using these values. Mu naught mean this value, which we need to check. Simply a value here belongs to h naught. Okay, sigma given, I think it's given, right? 1 in the 20s. Standard deviation given. See this one, 2.88. This is your sigma standard deviation. So it is known. You know what is n. So easily you can calculate what critical value. Okay. So then you can decide whether you need to use critical value approach or p-value approach. Okay. As a rule of thumb, I would say it is easy to use critical value approach. Sorry, use critical value approach because once you come up to this, once you solve this, I mean, once you can find C, that C cal value, then easily you have to convert this this alpha to like C alpha, right? That C value. Then you can compare. But anyway, I don't know which method they have used. Okay, first critical value approach. X bar, they have calculated X bar this much, 64.24. Okay, so as they mentioned in step, first step, H naught, this one versus HA. Okay, since it is greater than, it's greater than. So this is right tail test, which mean like this. Okay, this is your rejection region. Okay, so if you use critical value approach, you have to find what is this value here, right here. We call this C alpha. Okay, okay, significant level this much, since it is right tail, just one tail, this is alpha. So okay, they have calculated your C cal or critical value, it is 2.85. Next, you have to calculate C alpha. So this is the alpha. So where's the C alpha? 233, right? Based on that, 233. Yes, C alpha, which means C 0.01 value is 233. It is a positive value because it is right tail. So you can see here, C alpha value is somewhere here. Your C cal is somewhere. Sorry, not C cal. Yeah, C cal. Sorry, C cal value is somewhere here. So it is inside the rejection region, right? Let me check. Test statistic value greater than critical value. Yes, which means C cal greater than C alpha. So what you have to do? Therefore, reject H naught. I don't know what happened here. Here they merge. I'm so sorry for this. I'll correct this one. Okay, I think when I copy and paste, something has happened. Anyway, this has mentioned the value C alpha. It is 2.33. That's what they have mentioned here. 2.33. Okay, so since case is like this, you have to reject H naught. Finally, you can say, okay, starting from here, at 1% significant level, or you can say, therefore, alpha equals 0.01, we reject null hypothesis, or you can say we reject H naught, that's fine. We have enough evidence to say that since we are rejecting H naught, we have enough evidence to say your HA. HA mean enough evidence to say that this one. This is the researcher's hypothesis or researcher's claim. Okay. If in any case you do not reject H naught, you have to say we do not have enough evidence to say researchers claim, right? Okay. Okay, there is a p-value approach as well. I'm not going too much detail. X bar you can find. This is H no. This is hypothesis. C-cal value, it is same. You have to do is you have to convert your C-cal value to a probability value using a standard normal table. Okay, so that that probability is what? Do you remember for the right tail test how you calculate p-value? It is equals to 1 minus delta, right? So same here, once you get the probability for this value, you will get this much, 0.9978. Once you check the table, you will see that. Then get the 1 minus, and this is your p-value. So your alpha value is 0.01. Compare these two. This one is what? Greater than this one, which means reject H naught. Yeah, right? Clear? So same interpretation. Okay. You can use either p-value approach or critical value approach. No need to use both. Yes, just use one method. Okay, that's it. If in your question they have mentioned you have to use p-value, specifically p-value or critical value, then use that. Otherwise, it's your choice. Okay. In this example, left tail test, which means something like this. This is your rejection region. So they have given sample size 15, mean daily charge 70, significant level 5%, which means 0.05. So what do you need to find? Operate in South Carolina is less than this much. So this is X bar, right? X bar given, alpha given, N given, where is sigma? Yeah, it is 2. Yeah, this one. This is sigma. Okay, this is what you need to find. This is your what? This is your mu naught, right? Clear? This is your mu naught. So keyword is less than. Okay, so your alternative hypothesis, it looks like mu less than mu naught. Okay, mu naught is this is 75. Okay. So same as previous, this is X bar is 70. So like this, looks like, yes, this is correct, alpha this much. So once you use critical value approach, it doesn't matter whether critical value approach or p-value approach, calculate your C-cal or critical value C. It is negative 0.87. Then since it is critical value, you have to find C alpha. I don't know what is the C alpha value. C alpha is should be 0.05, right? So C 0.05, critical value gonna be 164 something, 1.64, I guess. Yeah. Since it is left tail, it's gonna be negative. This is alpha. Yeah, see, oh, 4.5, sorry, yeah. Okay, see, they have given 4.5. So this is your critical value, C cal. This is C alpha. Okay, so you know this critical value is greater than your critical value greater than your C alpha, then reject or not, do not reject. Therefore, you cannot see here, do not reject, right? Since this is the case, you do not reject because your C cal is somewhere here, your C alpha is somewhere here. Okay, so your C alpha, C cal, it's in do not reject area. So we do not reject. See, check this one. So your final conclusion, it's like, okay, therefore at this significant level, we do not reject the null hypothesis. Therefore, we do not say, see this, we do not have enough evidence to say that researchers claim, okay, whatever they have mentioned in the question, that researchers claim. Clear? This is how we give the conclusion. I mean, it is very, very simple way, okay? You don't have to write like a paragraph, just these 2 sentences enough, okay? You have mentioned what is the significant level and what you should, I mean, what is your decision, and then what is that in words, okay? Same here for the p-value approach. Up to this point, it is same. Once you calculate the p-value, you will see that same result. Do not reject. Okay. So interpretation is same. For the two-tail case, alpha two-sided. In this, okay, this is just a name. Okay. For the two-tail case, I normally I don't say, but we call this alpha two-sided significant level. Okay, but I don't know. I normally call significant level alpha. That's it. Reject test note if two-tail test and confidence interval. Okay. Do you remember this guy? Confidence interval in chapter 7. Okay. Let's check this one. Two-sided significant test. Okay, this is two-sided. Oh, you can say significant test. Reject S naught exactly when the mu naught, this is what they have given. No, we need to check. Falls outside the level of this much. What is this? This one and this one together? It is 1 minus alpha 100%. Do you remember that? Okay, that interval inside this. These are the rejection region, or these are the intervals that we bound. Okay, so confidence interval for mu is something like this. This C star you can find in the next. This is 1 minus alpha % confidence interval. Okay, this is the interval we are interesting. The same idea behind the confidence interval. Okay, there's no new things here. Okay, clear? Here confidence interval, because I told you last day we can combine confidence intervals to this particular question types. Okay, so last year, okay, I think first one is for the reject, do not reject case. Let me check. Certain level was this much. N is 30. Okay, and then mean running time of those 30 were found this much. Okay, once you read this, you will figure it out what is this 8.5 and what is this 8.6 hours. This 8.6 based on 30 light bulbs, which means this is your correct. This is your X bar, and this is what they have given in the first sentence. It is your mu naught, right? Clear? Assume that the population standard deviation, okay, sigma given, population standard deviation given, support, okay, this is the researcher's claim. Now, here they haven't mentioned anything about population, okay, but the situation is this example I took from Math 2300, okay. In Math 2300, we consider sample, it is large enough when the sample is greater than or equal 30. Okay, when the sample is greater than or equal 30, we consider we can approximate to a normal distribution. Okay, your case it is 40, but just for a moment, just think about this is you can consider as a normal distributed, I mean approximately normal distributed case. Okay, That's why I put this example in this part one. I mean standard C-test case. So you can use C-test. Okay, you can use C-test. For a moment, just forget about this 30. Think about you can use C-test. Okay, I didn't see this value. That's why. Otherwise, I'll change that. I'm so sorry I didn't see this. Okay, anyway, significant level, it is given this much, alpha 10%. Okay, let's go. Okay, first one, you have to find, you have to decide whether you reject or do not reject. Mu naught 8.5. So this is what, okay, sufficient to provide mean running time of new bulb is different, which mean not equal. Okay, different mean not equal. So that's why it becomes two-tailed test. Okay, not equal this much. So n given, yes, x bar given, alpha is 10%, it is 0.1. Sigma given, because sigma known, yes. Calculate with C statistic or test statistic, C cal, it is this value. Doesn't matter about this sample size, okay, just forget about that. Critical value this much, since it is two-tail, you have to take alpha over 2. Okay, don't forget that. Then find these values. This is C alpha over 2, and this is negative C alpha over 2. Okay, same value but different sign. Okay, because it is symmetric. Yes. Now what? Okay. Once you calculate this, I mean the numerator, yes, this value is equal to 0.1, but this value, it is nothing to do with alpha. Okay, there is no connection with alpha. Okay, it is different case. I mean, it is different and this is different. Okay, don't confuse with that. Alpha is something else. Alpha is yes, alpha given. Alpha is given, right? See here, alpha is given. Oh, sorry. Yeah, alpha is given. So since it is two-tail, you have to take like this. Okay, let's check these values. 645. Sorry, I don't know. Once I press this button, everything goes down. Negative 1.645. So you have a 1.645. What is your C value? 1. So 1.11, it is somewhere here, right? So you can see that your value is inside the rejection region, right? So you do not reject H0. Clear? Okay. Don't confuse with this 2 times delta. It is for p value. It is not for the critical value. Okay. See. Okay. So you do not. It's not the rejection region. So you do not reject H0. Conclusion. You know how to deal with the conclusion. Do not reject H0 at. You have to mention that. Okay. Significant level. Don't forget it. In your conclusion, alpha should be there. Okay. Okay, what they have asked, also calculate the 90% confidence interval for the population mean. So do you remember how to calculate confidence interval? Okay, x bar plus or minus C alpha over 2, Y alpha over 2, because it is confidence interval. It's not about two tail, one tail, it is about confidence interval. Always for the confidence interval, we use alpha over 2. Okay. Sigma over square root of n. So once you calculate, you will get these two values. So this mean mu naught See 8.5. What is your mu naught? Mu naught is 8.5. Once you check this interval, see 8.45. I mean, starting from here and from here. See, this guy is somewhere here. So you do not reject, right? You do not reject, yes. And also once you check the confidence interval, you will see that that value 8.5, it is inside the confidence interval, right? It is something like this decision is correct. Okay, clear? So once you do not reject and find the confidence interval, this should happen, okay, in your questions as well. Please remember that. Once you do not reject, but once you calculate the confidence interval, it is somewhere here or here, then there's a problem with your calculations, okay? So please keep that in mind. Yeah. Okay, this is the confidence interval. What is this two-tail again? Okay, I'm not going to do this one. Please check this once I upload this note on the Blackboard. Okay. What kind of test is this? Differs from mean, not equal. So it is two-tail. Yes, two-tail. Okay, I'll show you what are the numbers. So this had mean length x bar is this much. Report on low link, the mean length of okay, this is your mu naught, right? This is what researchers are talking about. This is 100 randomly selected. This is from sample. Okay, so this is your x bar, this number. Clear? This is your alpha. So once you read the question, try to figure it out what are those values. Okay, actually you don't need to read the entire question, just skim it and find the stuff. This is this, because of this keyword, it is less than or equal. Okay, so once you check, you will see, yeah, you will see this, and this is how we deal. Okay, again, I'll adjust these merging problems in you once I update this one. See this picture on top of this sentence. So yeah, it is my mistake. Anyway, clear? Okay, case one done. Case one based on a C test. Okay, we know population is normal distributed, so no problem, we can use C test. This case, large samples. So for the large samples, which mean in your case n, simple n, greater than or equal 40. Okay, so in this case, you don't need to know about the population. You can approximate your sample to a normally distributed sample. Okay, so this based on approximation. This assumption, I think, yes, this is the assumption. For large n, which mean n greater than or equal 40, mean is approximately normally, sample mean is approximately normally distributed. So see, you don't have to know about the population. That's fine. Okay. If they haven't mentioned anything about sample size, like if they haven't mentioned sample size greater than 40, they and they have mentioned population is normal distributed, then no problem, you can go with case one, which means C test. If they haven't mentioned about the population is normal distributed or whatever, and you know sample is greater than 40, no problem, you can use this case number 2. Can you guess what test we are going to do? It's going to be T test. Okay, because you remember that, right? Once we need to approximate, we use t-test. Oh, yeah. Actually, you don't. In this case, you don't need to know about sigma. Instead of sigma, you can use S. Okay. Sorry. In this case, we can use C. Okay. I'm so sorry. I just confused. This case, we can use C. At what time we use C, t-test? Do you remember? We use t-test, right? Okay. Okay, that's fine. I'm not going to confuse you. Okay. Case 1 and, oh, sorry. Case 1 and case 2, you can use, for these two, you can use C-test. Okay. Clear? We use t-test for samples less than 40, and also they haven't mentioned about the population, which means combination of case 1 and case 2. That case you will see in case number 3. Okay. So I just confused. I thought that this is case 2. Okay. Anyway, you don't need to know about sigma. I mean, if it is not given, yes, assume it is S, which means sample standard deviation. Okay. Rule of thumb, this one. And again, once you do your research, please don't consider it's like this. This is something, this is not a rigid boundary. Okay. So again, you can calculate, but here replace sigma by S. Okay. Most of the time, if we have to approximate our sample to a normal distributed, then we don't know about the sigma. Almost all cases we don't know about the sigma. So you have to replace sigma by S. Okay. When approximate is a normal when H naught is true. That's why for that case you can get your mu naught, because H naught is mu equals mu naught. Once this is true, then you can use mu naught here. Okay, same as previous case. We always assume H naught is true in the first place and do our calculations. Okay, clear? Rejection regions calculated in case 1. Yes, exactly the same case, same way we deal with this kind of problem. Exactly same. Okay. Significant level, now it is approximately alpha. Yes, still we are using alpha, but since we since we approximate to a normal distribution, the thing is this alpha is also approximate alpha. Okay, but doesn't matter, we use the name alpha. Okay, that's it, significant level alpha. I think it is enough to do just one example for this case. Example here. Or not, these are not examples, these are just hypotheses, right? They claims the mean weight is this much. So H naught, H1, oh sorry, HA. Okay, so mu here. So what they, okay, mu. So this is two-tailed test. First one is, oh yes. See this one. Is this much. So is this much mean this is not equal. Okay. 566, 566. Okay. Is this much. So this is your hypothesis. So okay. Okay, this is a question. Yes, I thought that this is three different things. Not this is same question, just one question. 50 quarters. So what is your n? N is 50. Mean weight of, okay, mean weight, which means x bar. Standard deviation based on what? This sample. So this is your S, this one. Okay, just forget about the units, gram, just forget about that. Test the claim that the mean weight of this one calculation is this much at level alpha this much, alpha is this much. Since it is two-tailed test, you have to consider alpha over 2. Okay, so same case here. This one, this is given, this one. S given, yes, sigma unknown, but n greater than 40, n is 50. So this is true. Calculate C alpha or C, not C alpha, sorry, C cal or a test statistic, C statistic. This we call test statistic or C statistic, that's fine. Okay, or sometimes we denote this by C naught. Okay, whatever, C naught, C cal, that's fine, whatever you use. Okay, critical value, they are talking about critical value, or yeah, critical value. Yes, for the critical value case, C alpha over 2, you need to find C alpha over 2, this one and this one. So you know these two values. Now you can compare these two values. What happened? Negative 1 point. So this value here, it is somewhere here, right? Am I correct? Right? Yes. So what happened? Do not reject, right? Yes, do not reject. Okay, you don't have to write this one. This is your decision how you take it. Keep it in your mind and write the conclusion. Okay, do not reject H naught at this significant level. So we do not reject, yes. So we do not have enough evidence to say the mean the researchers claim. Okay, so this is these two little bit important. First sentence and the second sentence, especially from here to here. Okay,